Let's try an example. Calculate the critical value, or t, that is needed to construct a confidence interval for means given that the confidence percentage is 90% and the sample size is 25. Unless it's otherwise specified, always use the two-tail part of the table, as that represents both ends of the bell curve. So to begin, we need to take our confidence level, 90%, turn it into a decimal, and subtract it from 1, giving us 10 hundredths, or 1/10. And that means that the degrees of freedom is equal to n minus 1, so 25 minus 1, which is 24. And then in order to find the critical t value, we need to use the table to determine what it is. So we have the level of 10 hundredths, or 1/10. Then if we go down for the degrees of freedom to be 24, we end up at 1 and 711 thousandths. Here's another example where we have to find the confidence interval. Two friends go to their weekly pizza spot and order their favorite, a pepperoni pizza, to share. They notice that the amount of pepperoni differs each week and decide to investigate the average amount of pepperoni on the pizza at the pizzeria. The number of pepperoni on 10 randomly selected pizzas are given below. Construct a 95% confidence interval. Let's get started. We need to use the four-step process in order to solve this problem. The first step in that is for the facts for F. We have a 95% confidence interval level, and we're going to estimate the true mean of the pepperoni in our problem. The next part of this process is the setup to make sure that we have enough conditions. Well, we have our sample value. We can determine the degrees of freedom based on the number of data points that we have here in order to construct our t-interval for means. The next step in solving is to perform our calculations. Well, we know that we have a 95% confidence interval, so we need to subtract 95 hundredths from 1 and use a level of 5 hundredths when reading the t-table, and our degrees of freedom is 10 minus 1, or 9. So if we switch over to our t-table and we read it, we have, here's our 5 hundredths, and we go down to the 9. So our t value, or t star value, is going to be 2 and 262 thousandths. Next, we need to determine the sample mean. So we can put our data points into a calculator, as is shown here, and then we can go to Stat, Calculate, one variable stats, and it will give us the sample mean of 17 and 4/10. And the standard deviation that we're also told here is it's the S and then X is that standard deviation. So it's 4 and about 926 thousandths. And we know that our n value is 10. And then if we put these values into our confidence interval formula, we have 17 and 4/10 plus or minus 2.262 times 4 and 926 thousandths divided by the square root of 10. So our ending step is, once simplified, we get a confidence interval of 17 and 4/10 plus or minus 3 and 524 thousandths. In other words, if we simplify that one section of our formula, the t-value times the sample standard deviation divided by n, or the square root of n, we end up getting that 3 and about 524 thousandths. They rounded it to the thousandths place. And if we do the addition, we will get the high number from our interval of 20 and 924 thousandths. And if we subtract them, we get our lower value of the confidence interval, which is 13 and 876 thousandths, with a degrees of freedom equal to 9. So what we can say in our final conclusion is that we are 95% confident that the interval from 13 and 876 thousandths to 20 and 924 thousandths captures the true mean number of pepperoni on a pizza at this pizzeria or pizza place.